Okay, so now we're looking at the second one, where we're saying a small block slides without friction along a track toward a circular loop. The block has more than enough speed to remain firmly in contact with the track as it goes around the loop. The magnitude of the block's acceleration at the top of the loop is something. So we want to know, we're saying, hey, we got this block, it's a good block, and it's going around this loop, and at the top it is firmly in contact with the track. So that's kind of coded. It's a little bit of us trying to figure out what they're talking about, but it just means, hey, we have a normal force. So if we're thinking about our force diagram, we can circle our box and say, okay, well, what things are crossing my circle? Well, it looks like I have the track crossing my circle, and that's pretty much it. So if I'm looking at this case, I can draw out, oops. Oh, yeah. Whoa, that transported me all the way up there. That's weird. Okay, so I can look at this and say if I'm looking at this force diagram, the force is acting on it is the problem told us we have a normal force, and that is acting perpendicular to the surface, so it's acting downwards. And then we also have a gravitational force. So our net force, our net centripetal force, these are both towards the middle of our circle, so they're both positive. So we have a positive gravitational force plus a positive normal force equals ma. And what the problem is asking us is the magnitude of the block's acceleration at the top of the loop, is it 0, greater than 0, but less than g, equal to g, or greater than g? So what we can say is, well, our acceleration is equal to fg plus fn divided by m. So if we're looking at kind of really quickly turning our gravitational force into our equation for it, where we say it's mg, we can do a little bit of algebra and divide that, but we'd still have to keep it there. But if we're looking at this, our acceleration is equal to g plus a term. So it looks like a has to be greater than g, because our acceleration is equal to g plus something. So by this case, we're saying, oh, well, our acceleration is greater than g, greater than 9.8. So it has to be greater than g.